So we've been working on the properties of radicals. So in previous videos, we already looked at how to simplify and multiply radicals using the product property. And then we've also looked at how to divide radicals using the quotient property and how to eliminate square roots in the denominator by rationalizing the denominator. So today is going to be kind of a review of all of those things. We're going to kind of put them all together. And so we're going to look at some different operations that we can do with radicals outside of just multiplying and dividing. So first thing that's really important is just like with like terms, when we're looking at polynomials, we have things called like radicals. So radicals that are like radicals have to have two things that are true. So they have to have the same index and the same radicand. Okay? So, for example, yes, like radicals would be the cube root of 7 and 6 cube roots of 7. The coefficients don't matter. This could be 2 instead of 1. The 2 and the 6, those can be different, but the point is that I have cube root of 7 and cube root of 7. Whoops, crossed that out by accident. So an example that would not be like radicals would be the cube root of 7 and the square root of 7. They both have 7s, but one's a cube root and one is a square root. Remember, we don't usually write that 2 there, but that might help you to see it. The cube root of 5 and the cube root of 6, those would not be like radicals because they don't have the same number underneath, the radicand. So you'll want to be on the lookout for those. And why? Because we are, just like with variables, we're allowed to add or subtract radicals, but we have to think of it the way we do with like terms. So for example, let's think about what we know just from basic algebra, okay? If I have the expression 2x plus 3y minus 4x, the only like terms that I have are 2x and negative 4x. Those are the only ones that I could actually combine. This 3y doesn't have a buddy, so I have to leave that one alone. So I would get negative 2x plus 3y. So notice the x's didn't change. That's just what we were counting. And so now I have negative 2 of them, negative 2 x's. And I have 3 y's left. Okay? The idea here is very similar. The expression 2 square root 2 plus 3 square root 5 minus 4 square root 2 is just like if this were x, y, and x. The only ones that are like radicals are the 2 root 2 and the negative 4 root 2. And when I combine them together, just like how we got negative 2x, I'm going to get negative 2 root 2. And the last one, I only have 3 square roots of 5 and nothing to combine it with, so it just stays negative 3 square roots 5. Or positive 3, I'm sorry. Negative 2 root 2 plus 3 root 5. That's your answer. We can't combine it any further than that because square root of 2 and square root of 5 don't match. We could multiply them, but we can't add them because you have to add like terms, or in this case, like radicals. So if we look at a couple of these examples below, we want to simplify the radical expression. Now, some of these have adding and subtracting. Some of them also have multiplying. Some of them have some other fancy stuff going on. So we're going to look at several different cases here. And then this is the end of this section. So for number 20, you see that I have a pair of like radicals. I have 5 square root of 7 and negative 8 square root of 7. So 5 and negative 8, that gives me negative 3 square root 7. And then the square root of 11 doesn't have any matches, so it's going to stay exactly the same. So I get negative 3 square root 7 plus the square root of 11. And that, folks, is the answer. That's all you can do with it. You can't simplify it more than that. Okay? Now, if you look at number 21, you might look at it first and say, but Miss Ramsey, there's no like radicals there, so that means we can't do it. That might be true. But we have to make sure that all of our expressions are simplified all the way before we finally decide that there's nothing we can do. So there's no fractions, there's no radicals in the denominator, so the only thing we have to check for is perfect square factors. So we say, are there any perfect squares that go into 5? No. Are there any perfect squares that go into 20? Yes. This is going to be the square root of 4 times 5. 4 is a perfect square, so that one is going to come out. The 10 root 5 is going to stay the same. We didn't do anything to that. But then we have plus the square root of 4, which is 2, and then the square root of 5 stays inside. Look at what that just accomplished for me. Now I have like radicals, and so I can finish this out. I'm going to get 12 square root 5. It all combines down into one term, which is good. Okay, so number 22. This is a distributive problem. It's kind of hard to tell, but what if this just said like 5 times x minus 4? You would distribute the 5. Same thing here. We're going to distribute the square root of 5. Remember, we are allowed to multiply what is under the square root. That is allowed. So, we get the square root of 5 times the square root of 3, which is the square root of 15. And then the square root of 5 times the square root of 75 is going to be minus the square root of, let's see, 150, 225, 200, 275? No, 375. That sounds right. 375. Okay. So, they don't match. So I need to see if I can simplify these to see if I can combine any like terms. There's no like terms, not like terms. There's no perfect squares in 15, so that's not going to work. But square root of 375, you're going to have to try quite a few numbers. But a good clue is that if the number ends in 5, you're probably going to divide it by something that ends in a 5. And so I've already played around with this, and the one that I found was 25. This is 25 times 15. So 25 is our perfect square. We get the square root of 15 minus 5 square root 15. And don't forget, just like with anything else, this is a 1 square root of 15. So now, because they're both square roots of 15, I can combine, and we get negative 4 square root of 15. So for the last one, don't forget the rule. You cannot distribute this exponent. You're never allowed to distribute exponents. There is no distributive property for exponents. I guess I should say do not distribute. Okay? So we have to think instead, what does it mean when I square something? That means multiply it by itself. 2 root 5 minus 4 times 2 root 5 minus 4. Now, we haven't done a problem like this in a while, but if you think back to polynomials, what we did was we did the distributive property 2 times. So first I'm going to start by multiplying the first term and the first term. So 2 root 5 times 2 root 5. Remember, we can only multiply the 2's that are outside. That's how I get 4. And then the 5's that are under, that's how I get the square root of 25. Then I can do 2 root 5 times negative 4. Well, this negative 4 is outside the square root, so I can only multiply it by the 2, but there's no square roots on it, so the square root of 5 is going to stay the same. Okay, the 8 came from 2 times 4, and then the square root of 5 just stayed exactly the same. So now we're going to do negative 4 times 2 root 5, the same way. That gives you negative 8 root 5. And then negative 4 times negative 4 is positive 16. So now we want to simplify everything and try to combine like terms. What I notice here is that the square root of 25 is a perfect square. So I get 4 times 5 here, which is really 20. And then I have negative 8 root 5 and negative 8 root 5, so that gives me minus 16 root 5. And then plus 16, so I have another pair of like terms here. So our final answer is 20 plus 16, which is 36. Not plus. Minus, not 18 either, sorry, I'm a mess. 16 root 5. And so this is all said and done. That's our final answer. So that one's a little bit challenging. You're going to get some where you have to kind of try some stuff that's a little bit tougher, but I think you'll be okay. So you will have an assignment over this. Don't forget that you have 2 other assignments over 9.1. If you finish early or if you have extra time in class today, I would strongly recommend that you go back and make sure that you don't have any other incomplete assignments from 9.1 because I'll be grading those tomorrow when I get back. So I hope you guys have a lovely Thursday, and I'll see you tomorrow.